Since I have nothing else to do, I thought I might as well try to understand these papers, and I finally came up with a set of objectives which will be our guide from now on. If you want to know how I came up with this, well, I'll leave some links in the description. You'll have to figure it out for yourself. Now that I have the requirements clearly set down, there's no excuse for slacking off. I can't just do some random stuff and call it progress. The first thing on our list is loop resistance, and the biggest contributor to that is the projectile and the rail projectile interface. It took a few iterations to come up with this design. It takes a little effort to make this projectile, but the result is quite springy, which leads to a surprisingly low loop resistance of 1.2 milliohms.
Why are we still here? Just to suffer every night.
Now that I have the parts, it's time to start work on the cap charger. First, a capacitor that came in its own packaging with a separate bill for some reason, a costly MOSFET that may be a bad choice since it's hard to find, a couple of high voltage high current diodes, shunt resistors, and of course a bunch of very small O4O2 passives. First is the painstaking process of applying paste to the pads, for which I use two safety pins. I should get a stencil next time. Then placing the capacitor, the shunt resistor, the transistor, and the diode. I placed the O4O2 parts off camera since it needed a lot of concentration and took me a good half an hour. And finally, hot air everything. I wanted to keep the temperature low at 200 degrees Celsius, but nothing happened, so I turned it up to 250 and it was done in no time. I had to perform the customary visual inspection, of course, which revealed no problems. I thought a change of lighting would be best to show how nice this thing actually looks, and it was shot on my bed.
Okay, so like I was supposed to do this 11 months back. It's been a year. Probably more than a year actually. So yeah, this is my screen. Okay, hardware is trash. Don't do hardware. Or else you're going to end up like that guy asking other people for code, which is just sad. It's sad. It's real sad. And yeah, so basically I was asked to code stuff like this. So they said if yes, then no, else yes. It was something like this, and I did it, hoping that and I sent the file, but you know like actually there's like a minute and a half left to this, and like I don't know what. So apparently I've just been called. It's been 11 months since the last update, not the last upload. Okay, and so like basically I took this file here and I like gave it to him. So that's it, yeah. So like that's how the code works. So basically like you've got an STM32, you've got a HAL, which is called a hardware application abstraction layer, and this basically allows you to type code without dying, which I did a lot of times. And then you've got registers, and they like do stuff, and yeah, so like that's it. Go look up Scatasium, subscribe to Scatasium. It's about 40 seconds remaining, so like yeah, so subscribe to Scatasium. It's been 11 months. Don't be like me, and like basically code. I sent code, it works, it does it does railgun stuff. I don't know why. Okay, yeah.
So, what started all this? I just wanted a toy to zap all my friends with. I wanted to build an electron gun, believe it or not, some kind of a taser sort of thing. I shoot two electron beams at a person, conductive of course, and then fire an arc through those electron beams and shock the said person. It was a fun time.
That's not really what I call fun.
Yeah, that's not really what you call fun, but that's how it started. I just wanted a toy, and now look what it's all become. I never expected any of this. And here we are, 4 years later. Now for the part that makes me the most nervous, actually testing a new circuit for the first time. First, make sure the microcontroller works as planned, which it does, and then turn the power supply on. Perhaps I should wear my earphones in case something blows up. That way I won't be deafened. Okay, I couldn't find them. I'll just go ahead and turn it on. Okay, no shots. That's a good start.
Well, that seems to
Hesitating
have
to
done the
press the
job.
charge button, and
It
bam.
just shot
Wait,
beyond.
what's that? The meter went off scale for a moment and settled down. That
Was that
sure did
supposed
give
to
me a heart
happen?
attack. Of course not, so I'll bring in my Agilent meter to make sure. Phew, it works fine, but it's a little slower than I expected. Now that it works, time for some probing. This is the drain, which is amazingly clean, true boundary mode. No wonder the FET is not hot at all. The gate waveform is an absolute charm with no ringing at all. And the current waveform? Oh wait, that's not very nice. In fact, it's terrible. Maybe it's the inductance of the long ground path. And the fix? This little thing that comes in a bag of probe accessories that's easy to dismiss. The long ground clip can snap off, which is the first time I'm doing it by the way, and this thing slips on. It provides a very low inductance return and allows us to directly probe between the leads of a component. Trying again, we see that the waveform is now perfect, and the peak value is 72 millivolts as stated in the datasheet, which corresponds to 9 amp peak current through an 8 milliohm shunt. Overall, this cap charger has exceeded expectations except for the speed, which was apparently because of the RC filter I added to the shunt. Removing it makes the charger twice as fast and adds a cool whine. At the end of the day, I have a reliable cap charger that is very quick and very efficient. It does not get hot at all. This is the new computer board, which is electrically identical to the old one except for the fact that it is well designed and does not have the fancy features of the old one. At least I got the STM32 package right this time. I've already populated one with parts I salvaged from an old broken blue pill. The USB-C port and the STM32 footprints are unpopulated, well, because I forgot to order them. And this is the new capacitor board that is mounted 2 mm above the body of the capacitors so that the base plates can fit between them and secure the capacitors to the body. These, I 3D printed them, of course. And yes, I have a 3D printer now. Since there are so many Ender 3 videos on the internet, I posted a short video about it on my second channel. And yes, I have a second channel too, link in the description. Now that I have a 3D printer, I was able to print all the body parts. It took only these many attempts to get it right. We begin with the capacitor PCB. The railgun is mounted on top of the PCB and the base plates slide in. Everything is held together using 4 M3 bolts. Then two spacers are fixed between the plates to keep them from moving too much, and then the handle halves are attached, secured by the posts inside. And then come the two halves of the shell, each attached using two M3 bolts. I recently came across this Japanese YouTube channel. Well, it's not really true. I've had some of his videos on my playlist for quite a while. Pons, as this person is known, has been working on railguns for quite a while now and he actually has something to show. This video shows one of his railguns shooting a, well, thing and it blows it away. Another video shows it making a hole in an aluminium can from quite a distance away. Though it uses a 1.5 kilojoule capacitor bank and long glossy wires, it's still an incredible feat. He even has a blog with a lot of interesting stuff including power electronics, which leads to a Twitter handle too. These pictures look interesting, but I don't understand Japanese. Fortunately, technology can help me out. Inductance versus position. Looks like this guy is serious. So, have I been defeated in creating a small railgun? Not yet. This is only motivation. Time to start working.
Listen, child, listen closely. I'm the wild. Life controls me. I'm exiled. I'm already home. Walking through a deconstruction to the woods. Introduction, something new. Oh. Close your eyes and open wide. Cut every time I was back. I'm not surprised. Could you hold a little more? A holiday is what we've waited for. Take control, say goodbye. So long, my friend, we'll see you in the sky. We can wait up through the night. Oh, damn, my friend, it's not me.
And it's a wrap.
So, what would you like to tell people of your age?
Quit Instagram.